Hello everyone, I am Masudur Rahman, a PhD student in the Department of Computer Science at Purdue University. I am sorry that I could not attend the workshop in person. I would like to thank the workshop organizer for giving me the opportunity to present our work through this video recording. I'll be talking about morality in decision making, a causal approach. Feel free to email me if you have any question or comment about this work. Consider the scenario of contextual multi-arm bandwidth. In this problem, in each iteration, an agent has to choose between arms. Before making the choice, the agent observes the contexts associated with the current iteration. The goal is to generate an optimal policy which maximizes the expected gain or rewards. This is a classical reinforcement learning problem that exemplifies the exploration and exploitation trade-off dilemma. On the other hand, this is the scenario with unobserved confounders, when the context impacts rewards along with the action. It has been shown that the general bandwidth algorithms do not guarantee an optimal strategy because of the presence of unobserved confounders. For a detailed analysis, please refer to the following paper. As an example, let's consider the following scenario. You operate an autonomous car and want to go to the university campus from your hotel. And the reward is given at the end of the trip when you reach the destination. A tip or reward is given if the agent reaches according to your time preference. Note that the agent is not aware of the user preference when it starts. It only observes the reward after it reaches the destination. Thus, an additional objective in this task is to learn user preference along with choosing optimal action to maximize the reward. In this case, an optimal policy for the autonomous agent would be to take the action with highest speed. In all the optimization scenarios, the agent only focuses on action that optimizes the reward. But what if we have an associated moral value with each action? Note that there are lots of literatures about morality, and it is very challenging to come up with a perfect definition of moral value, as it might vary between societies to society, culture to culture. Thus, we make explicit assumptions and build our model with these assumptions. The first is that we will be given a morality order of actions. By that, I mean, in the autonomous driving scenario, if the speed limit of a road is set as 70, then going with speed limit above that is considered as the low moral action. The second assumption is that we will be given a set of moral norms. We will incorporate these into the agent's decision making process. Note that depending on the application and the culture differences, this set might be different. Exploring this in details is out of scope of this work. Third assumption is that we know the impact of actions on these norms. This information can be in any form of arbitrary function. For a specific example, we can see the actions, different speed, impact number of accident and number of traffic ticket. And finally, we can define the moral as the function of these moral norms. For a particular instant, we can say if no accident or no traffic ticket, that action is moral. Now we have all the materials to define moral decision making objectives. We now have two objectives to optimize. Intuitively, we want to take action which produces higher expected task reward while violating less number of moral norms. Thus, we define optimization objective as follows. Take action which is necessary and sufficient to complete a task goal among all possible actions, which has higher moral value. Here, the challenging part is to decide whether an action is both necessary and sufficient to complete a task. Fortunately, we have causal tools or engine which can answer such query. Now, I will focus on one of such tools that we use in this work. Now let's discuss about counterfactual reasoning. The first term y sub a1 equals to 1 indicates the agent would have received the reward if it took action 1. And similarly, the second term y sub a0 equals to 0, which is the agent would not have received the reward if it took action 0. We can estimate the joint probability, which is called the probability of necessity and sufficiency of the action. This probability can be estimated from experimental data, simplistically through randomized trial. For details, I strongly recommend these books by Pearl. In particular, this analysis can be found in Chapter 9, Probability of Causation, in the first book. I would like to briefly mention about the experiments that we have done. For the bandit problem, we modify a popular Thompson sampling algorithm and incorporate morality in the decision-making process. We call it moral Thompson sampling. As the baselines, we consider random agent which randomly take any action and general Thompson sampling which take action optimizing only the task goal and ignoring moral dependency of actions. In the figure, y-axis is the probability of choosing optimal moral actions and x-axis shows the number of trial. We observe that moral Thompson agent quickly reaches the optimal probability near to 1. On the other hand, both random and general Thompson fails to reach the optimal moral policy. Interestingly, we see that the general Thompson agent, which is shown in the red line, performs worse than the random, as it converges to take actions with highest task level reward only, which often produce higher moral violation. In summary, in this work, we propose a combined decision-making approach which takes into account both task and moral goal. Simulation results show that moral agent achieves higher morality in decision making while showing comparable task-specific reward compared to the task goal-specific agent. I will stop here and I would be happy to answer any question via email. Thank you for your attention.